In part 3, we will take an exponential decay model. In part 1, we revised actually how exponential equations work. In part 2, we took one exponential growth model and did all the possible asset equations, right? And in this part, in part 3, we will do exponential decay model. Okay. So first, let's see actually what is exponential decay model. So it is y is equal to, okay, let's say output is equal to initial value. See, we will keep on revising these terms, right? So that you become used to it. Okay, so that is initial value 1, because it's a decay model, 1 minus rate raised to the power time. Now, time here is input because that is your wish. How much time you want to do the experiment. And after that particular time, how much radioactive substance is left, that is output, right? For example, after 4 years or 5 years, is it years? Yeah. How much radioactive substance is left, and initial value means what amount of substance you took in the beginning when you started the experiment, right? So it is like y is equal to a 1 minus r raised to the power time t, or let's say here, if we are doing it y and x terms, let's say it's x. And in this equation, it is written as amount after time t, right, is equal to initial value, which is 200, 1 minus r is replaced with decimal 85 raised to the power t. Okay, so that means this is the initial value, this is the output. That means after this much time of years, this much radioactive substance we have. Okay, now let's see this a little bit more. At place of 1 minus r, I have decimal 85. So r is equal to, I am doing it like how it is expected in SAT. Writing, adding r on both sides, subtracting decimal 85 on both sides is not a good idea if you are giving a SAT exam, right? So you have to learn how to do it directly. So r is equal to decimal 15 or 15%, right? So okay, if it is written decimal 85, don't say it's the decay factor. Use 1 minus r is actually this. So what is the rate of decay? Very important point, right? If we are in a little bit of stress situation or situation to perform, we forget certain things. So practice enough so that you can remember why 1 minus r is actually decimal 85, because sometimes you will see the equation like this. Now this b is okay. Now okay, b is the growth factor, the decay factor, and you will immediately write it as decimal 85. No, remember to find the rate, subtract it from 1, right? So rate is 15%. Okay, now we have analyzed the situation too much. Let's do the question. And there is a game here. Maybe this answer is not correct. So we have to check the option given is here is right or wrong. What is the initial amount of the substance? Okay, so that is the initial value, we know that. So which is 200 grams. Yes, that's the right answer. Decay factor interpretation. The percentage of substance that decays each year. No, decimal 85. What is decimal 85 here? It's always, if you see, it is always the decay factor or the growth factor. Now we are doing the decay model, so it's the decay factor. Decay factor meaning 15% of the substance decays each year. This is what we have done here. 15% of the substance decays each year. Okay, that's B. Now we will calculate. computing values. What is the approximate amount of substance remaining after 4 years? Now, what is given? Time. And amount is the question here. So that means 80 is the question here. 200 decimal 85 raised to power 4. This is what is needed here. So if we just calculate it, okay, you know, as in SAT, it's calculator is allowed throughout the exam. So let's do it. It's something like, yeah, that's the answer. So this is 104. Okay, here no option is showing 104. Let's say this is 104 approx, because it's approx and all the integers are there. So 104 is the right answer after rounding off. Okay, half-life. Mostly you have listened this word. What is the half-life period of this radioactive substance? So half-life means amount is half that of the initial amount. So what's the initial amount here? 200. So what will be the half of it? 100. Decimal 85. How long? How long? Now time is needed. So dividing by 200 on both sides is equal to decimal 85 raised to the power time. Now we have to come to log. Let's say the conversion. A raised to power x is equal to y. Suppose this is the exponential situation. So log of a of y is equal to x. So that means this power is actually the variable here. So time is equal to, okay, that will be 1 by 2 log of decimal 85 1 by 2. Just see the conversion carefully. So t is equal to log of decimal 5 to the base decimal 85. Okay, let's put the values in the calculator. So time is equal to 4.26502. Now if you round it off, that is 4 years. Okay, that is the wrong answer. This we have to check. D is not the right answer. Right answer is 4 years. Let's come to the next question. Reverse problem. How many years? Now what is missing? Time, right? 25 grams of substance remain. That means this is the final amount. So 25 is here. That is equal to 200.85 raised to the power time. 200 dividing by 200 on both sides, it's equal to decimal 85 raised to power t, which in turn is 1 by 8. Okay, now let's again apply log. Log of decimal 85, this becomes the base, this becomes the power, becomes the equal to value output here, and this number becomes the value of log. Okay, decimal 25, decimal 125 is equal to 2. T, again use the calculator. So T is equal to 12.7950728454. That means 12.8 or 13. So 13 years is okay. This is also correct. Only one was not correct. That was not correct. Okay. Writing equivalent form. We have already done that in the beginning, you know, when we were doing the concept. So A of t is equal to 200 decimal 85 raised to power t. A of t is equal to 200 1 minus 1.5 raised to power t. So 1 minus r raised to power t is actually in the equation. So r is the decay factor, which is 1.5. So yes, A is the right option. Okay, comparing two decay rates. Bt is equal to 200.75. See, now it's important here. Calculate R, decimal 75. Decimal 75 is 1 minus R. So R is equal to 1 minus decimal 75. That means decimal 25. And in our actual situation, what is R? It's decimal 15. So this decay rate is higher. That means it will decay faster. So which substance decays faster? AT because its rate of decay is smaller, AT because its decay factor is greater, BT because it loses 25% each year compared to 15% for AT. So yes, C is the right option. I think, yeah,